So on this first one, it says Mrs. Baker's 20-kilogram dog, Lexi, will wait patiently at her feet till she throws the ball. So can you go ahead and diagram your forces? What forces would be acting on her when she's patiently waiting there at her feet? Anybody drawing a dog? Because if you're drawing a dog, should you be drawing a dog? Nope. Remember, no matter what the object, you're going to draw that object as a square. If you want to include the dot in the center to represent that center of gravity, that is fine as well. Are there any buzzwords in that first part that would indicate whether it is balanced or unbalanced? Yeah, she's waiting. So if she's waiting, is she moving? No. So when you see that they're waiting, that means they are at rest. So my forces are balanced. So what force do you have down? Gravity. What force opposes gravity? It's a regular contact with the ground. Yeah, the normal force. All right. Can we calculate the force due to gravity or the force normal? Do we already know what the net force is? What's the net force? Good. Why is it 0? Yeah, forces are balanced. If the forces are balanced, I know the net force is 0, and I know instantly the acceleration of the dog is also 0. Okay, so there I have my free body diagram. I have my net force. I have my acceleration. Boom, that's pretty good. Now, FG, force due to gravity, is the same thing as their weight. Do you remember from last week, how do we calculate force due to gravity? Mass times the acceleration due to gravity, which we symbolize as G. So the mass, what was the mass of the dog? 20 kilograms, okay. Anybody remember what the acceleration due to gravity is? It's the number you guys start learning. There is an 8 in there. 9.8, there we go, 9.8. All right, so I just need to do 20 times 9.8. So when I do 20 times 9.8, and guys, this isn't going to be, I didn't put it to the correct sig figs, so don't be too upset since it doesn't have the correct number of sig figs. My answer is 196 newtons. Okay. Technically at the top, since I just wrote 20, I should have 1 sig fig. Right now, I did not answer it to sig figs. We're just at the beginning trying to learn how to do these problems, so I'm not going to be too crazy with sig figs on you right now. Okay? Now, what would be my normal force? Mackenzie, you said the forces are balanced. So if my forces are balanced and the force down is 196, what would be the force up? 196. Boom, done. Now I could also solve that another way. I could say, well, my force net, which force was up again, so it would be positive, normal. Which force is down, which would be negative? Gravity. So I know my net force is 0 minus my 196. So what minus 196 gives me 0? 196. There we go. So I could do it that way too in order to figure out a force. You would do it that way especially if you did have an acceleration and you know your net force now. Otherwise, though, if it's balanced, you should just be able to recognize, hey, up and down, they're equal. If the object accelerates to the right, the forces up and down would be equal, right? If it has a negative acceleration because it's slowing down in the x direction, that means up and down, force gravity, force normal, are going to be equal. All right, check this one out. So the story continues. Once the ball is thrown, Lexi will exert a force on the ground and causing her to accelerate up at 2.1 meters per second squared. Diagram the forces. Okay, so let's go ahead. Let's get a new free body diagram. Gravity's still pulling her down, but now she's off the ground, and what is being pushed up? If the dog's going to jump in the air, what force would be up? Applied, right? Now, it says that they accelerate up. I should make sure that this arrow up is way bigger then, because it's going to accelerate up. So I'm going to change mine and make it just a little bit bigger so that it looks more like the force up is greater. All right, so it says solve for mass, net force, gravity, and my force applied. Well, my mass, this comes back, it's the same dog, right? What was the mass from earlier? 20 kilograms. Will the force due to gravity change for the dog, even if they're jumping up? No, that won't. So I'm going to come back to the top, and I had 196. So that's still 196 newtons. But because it says that she accelerates up, I know that the forces are balanced or unbalanced. Unbalanced, right? So instantly I know they're unbalanced. So force net does not equal 0, and the force due to gravity, which we already got, was 196. All right, how can I solve for force net? What's Newton's second law? F net equals what times what? Yeah, mass times acceleration. You got it, guys. So I don't know what the net force is, but I know the mass is 20, and I know the acceleration is 2.1, right? Because it's given to me. So I'm going to go ahead and multiply then 20 times 2.1. And what do you get? How much? 42. And now the acceleration was positive because it was up. So I know my force net is a positive 42 newtons. So if I'm trying to figure out force applied, there's two different ways we can do this. Show of hands, how many people are more of the visual learners? Who likes to look at the arrows and say whether they're balanced up and down or not? Oh, wow, not many of you. Okay, well, let me show you that way first, since it seems like most of you guys don't want to use it that way. That's okay. So if my net force is 42 newtons up, that means that the force up is greater than the force down by how many newtons? 42, yeah, right? So if they were balanced, it would have been 196, but I know that the up is greater by 42. So then I would have to add those together, and I get my force applied is 238. And newtons, remember our unit for force is newtons. Okay. The other way that I could have done this, I know my force net, the force up is positive, so applied, minus the force due to gravity, because that's negative. So I'm doing the sum of the forces, but since down is negative, it subtracts it, because you're adding a negative number. So if 42 equals my force applied minus 196, how do I solve for that if I'm in math class? Yep. Add 196 to each side. And I'm going to get the same answer. What was that? 3, 238 newtons for my force applied. Okay. So as you're solving and you're taking a look at each of these steps, try to break it down and figure out, well, what information do I have? What information can I solve for? What are my forces that are balanced versus unbalanced? Okay? All right, last one that I got for you guys to introduce for today. Take a look. Here's our free body diagram. First thing you should notice, are my forces balanced in the y direction? Yeah. So will the object accelerate up or down? Nope. All right, look in the x direction. Are those balanced left and right? No. Which one's greater, the left force or the right force? The right. So that means the object will accelerate to the right. Now again, for my net force, for those that are out there that are visual learners, look at the left and right force. The right force is bigger, and it's bigger by 30 newtons. For those of you that are more of a math student, you would take your force applied minus your force due to friction, so 50 minus 20, and you're still going to get the same positive 30 newtons. Remember, with our net force, we do want to include positive, negative, because it's going to indicate the direction of our acceleration. Okay. All right, so now I have force net. I want you to get your mass. How can I solve for mass? Any guesses out there? Just solely based upon what is currently given. Do you agree? If I already had my acceleration, could I do F net equals ma, solve for mass by dividing by the acceleration? That would give me mass. So that's one way I could do this, but do I have the acceleration yet? No. All right, so one of the other forces got to be able to give me then my mass. Would it be friction? Not friction. Yeah, why gravity? What's my equation for gravity? Yeah, mass times my acceleration due to gravity, which is m times g. Well, that's 210 equals m times, what's g? 9.8. I only have one variable there. So can I solve for it now? Yeah. So I'll go ahead and divide by 9.8. Divide by 9.8. Sorry, my board's starting to get a little cluttered there. So go ahead, take your 210 divided by your 9.8. What did you guys get for mass? 21.4? Awesome. All right, so I have my mass now, 21.4. And then units for mass. Close. Kilograms. Kilograms. Okay. All right. Last one I can solve for now is my acceleration. Well, I know force net equals m times a. It is up to you if you want to rearrange your equation first and then plug in numbers. Or if you would rather plug in numbers and just solve for the variable, that is fine. Okay, it doesn't take any more or less time. So I know my net force is a positive 30. My mass is a 21.4. And then I'm multiplying that by acceleration. All right, flashback to Algebra 1. What do I have to do to get acceleration by itself? Perfect. Divide by 21.4. Both sides. Do you guys notice how I included that positive sign for my net force? Why do you think I want to include that? Good. So I remember it's going to be a positive acceleration. So go ahead, take your 30 divided by 21.4. My acceleration is a positive 1.40 meters per second squared. There's our final answer. All right, so the math is starting to join our unit now. So we've done most conceptual things thus far in talking about our forces, but now we're going to start integrating some of those calculations. So as you get going, make sure if I tell you the mass, instantly you can get force due to gravity. If you know the forces are balanced, you now have your force normal. If you get a free body diagram like this, you could solve for net force and then use that to calculate your mass and your acceleration, or whichever one you are missing. Okay? Drawing a free body diagram, being able to identify, like up here, you guys were saying that weight was my key word. If you see a key word, write to yourself that, hey, that is balanced. Okay? So that you know all my forces up and down are equal, left and right will be equal, okay? That will help get you guys on a good track moving forward, because eventually we're going to start adding more and more to these problems, okay? So for today, you guys have a practice with the free body diagrams 2. Okay, so if you go onto Canvas, it says practice free body diagram practice 2. You will notice the types of forces, the scenarios are the same from Friday. But now we're adding on the math. So for you, it's a great time to double check, make sure that you feel comfortable diagramming your free body diagrams. If you lost any points on that activity, it's probably because you didn't make things a square. Remember, I had said it in the video you were supposed to watch, and then I also put it nice and big on the assignment. Make sure all your objects are a square, and then add your forces accordingly. Okay? So make sure, again, label all your forces. Gravity is always going to be down. Okay? If it says ignore friction or neglect friction, you don't have to include it. And then as you guys are working, if you get stuck, call me over. Let's take a peek at it. Or if everybody's stuck on the same one, we'll throw it up on the board and we'll try to work through it together. Okay? Today's a great day to be able to talk with another person. Okay? Especially as the problems are going to start to get a little bit harder, you want to be able to debrief and kind of chat with that other physicist. Because that's what you guys are now. Okay?